So today's lesson is going to be on friction. And we all know what friction is. Friction is basically a force that is opposing the motion. We have been drawing friction, and the symbol that we have been using is we've been using capital F with a lowercase f. And basically, it happens in between any contacting surface, not only just between solid and solid. I think we all get that if I have, say, a box and I'm sliding it across, say if I'm applying a force that's going to the right, if the object is moving to the right, we know that the force of friction is acting in between the contacting surface right here. But what you would know is that friction also happens in fluids, in between solid, liquid, as well as gases. So I don't know how much you know it, but say in between liquids, you could be having sharks. You know how your sharks. Sorry, this is my shark. And with the shark swims really fast. The reason for that is sharks actually have very very rough skin, and as the shark is swimming through the waters and the skin of the shark actually would create these things called the eddies. It's almost like turbulent kind of thing. But because of the makeup of the sharks, the little bumpy thing actually breaks up the eddies and actually have a lower turbulence. And I also mentioned the word turbulence. That's basically friction that's happening within gases, like an airplane flying and the air that's flowing through can cause turbulence. So those are examples of friction that are happening in between liquid and gas. But this unit, we're probably only going to focus a lot on the solids. So there are three different types of friction that you will need to know. If I were you, I would be making study notes for this. Okay, the three types of friction is, the first type is called the static friction. We use a little symbol Fs. Okay, it is the force that is preventing a motionless object from starting to move. If you ever try to push a very heavy box of textbook, you would realize that it's very, very difficult for it to get started. So the force that is opposing you to start is called the static friction. But once the object is moving, it now switched to this other type of friction that is called kinetic. Like kinetic is like moving, kinetic friction. And kinetic friction is the force of friction that is opposite when something is already in motion. And then rolling frictions are friction that are against objects that are rolling. And one extra thing is static friction is always greater than or equals to kinetic friction. Okay, so this is always greater than that. Okay, so same thing, textbook, really heavy box of textbook. When you're really trying to get it to start moving, it's the static friction is really, really big. But then once something is going, the forces required will be less because you're actually going against a smaller force of frictions. So that's an example or a proof to you why we say static friction is always bigger than kinetic friction. So it always takes more force to start motion than to maintain the motion. Okay, so more force to start a motion than to maintain a motion. Okay, and rolling friction is the least. And situations when friction is wanted. If you ever want to start to walk or stop to walk, you need friction. Can you imagine if there's no grip at all, no friction at all? Can you even open a door? Like, can you imagine you grabbing the door handles and you're trying to turn the doorknob, but then there's no friction? You can't do any of these, right? So it's like everyday motion, you must have friction. Walking, when you're driving, like wintertime driving would be a lot more dangerous because friction between the tires and the snow is really small, right? So if you need the grip, you need the friction. In order to stop moving, you need that, or in order to create any heat, you would need that. But then there are times that we don't want friction, or at least we want lower friction. Say car engine, we have moving parts, you want to reduce the friction. That's why people put like ball bearings or oil in between like engines to decrease the frictions, to decrease the heat that is present. Okay, so those are examples of things when friction we don't want. Earthquake is another type of friction, basically between the land masses, and that's not always what we wanted, right? So what can you do to reduce the friction? Okay, friction can be reduced by a couple of things. You can make the surface more smooth. You can use grease or oil to lubricate it. Use bearings in between the wheels and the axles. Streamlining. I don't know if you've ever seen like wind tunnel. Let me see if I can find the video. It was like a slow motion of this guy who takes like video of like slow motion, and they were taking them a video of themselves in slow motion when they're in the wind tunnel, and you can see their mouth like moving so quickly. But anyway, people use wind tunnel to actually try to streamline it. When people first make a first model of a car, what they do is they actually have a clay model that's made, and then they would put it through like a wind tunnel so they can see the actual aerodynamic of the car. And if anything, they would use like a tools to kind of file down anything that is catching the wind, the quote, the wrong way, like you want it to be more aerodynamic. So that's what streamlining it. Okay, use rolling friction. So Egyptians move really big stones by putting some logs on it. Hovercraft, right? Hovercraft, you raise it up so the masses is reduced so that you are reducing the frictions. And sometimes people use synovian fluid to kind of reduce the friction in the joint. Okay, now we're into the math part. Calculating frictions. So the equation to calculate friction is Ff, which is your force of friction, Fn, which is your force of normal. You know those two. The only thing you do not know is this symbol. Okay, this symbol is called mu. The sound of it is mu. It's a Latin alphabet, and it means the coefficient of friction. Okay, it is a number that I have to give it to you. Okay, if we want to use the magic triangle, I think I try to teach that to you. But if Ff is mu times Fn, meaning mu is beside Fn, we would put the mu to the left and Fn to the right. So I have Ff at the top. Okay, so that is for you to use if you need it. If not, you can rearrange the equation. So every surface have a coefficient of friction. And it's different between dry and wet surfaces. It all depends on, like, say, asphalt with rubber. It's going to be different with ice with rubber. Okay, like when we're in icy situation, force of friction becomes a lot less. The reason for that is the coefficient of friction is changing. Okay, so let's see how we do this. All right, so we got a question here. It says that we have, in order to start a 315 kilogram, so what symbol would that be? Something measuring kilogram. Hopefully you're good that we're saying that's a mass. So 315 kilogram bobsled to move in the ice, a horizontal force forward is 41 Newton. Calculate the coefficient of static friction. When something just starts to move, you are assuming that this is a first law type of question. You assume that the acceleration is 0. Okay, so you would start off these questions the same way as what we would do is we start off with the free body diagram. And then number 1, you're going to find the net force. Okay, remember the net force, we have X and Y. Okay, so we're going to start off with the free body diagram first. Okay, I have a bobsled moving on ice. I will have force of gravity that's going downward. I would have force of normal. There is an applied force going, and they're asking for what is the coefficient of friction. So the symbol they want is mu. They're solving for mu. So that means I'm going to have to use the new equation that they gave us, right? So I'm just going to go back and I'm going to look at my equation again. I need to solve for mu. So if I'm using the magic triangle, if I want the mu, Ff is at the top, Fn is at the bottom. Okay, so let's see where that takes us. So I'm just going to write the equation. Mu is equals to Ff at the top, Fn at the bottom. Okay, so let's take a look at the picture here. The first thing you need to realize is that the acceleration is 0. That means the forces are balanced. Okay, so let's take a look at X and Y. When the forces are balanced, Fa and Ff. So I have Fa minus Ff. That's my net force, right? Whenever I write my net force, I'm going to write my net force for Y It's going to be Fn minus Fg. But the key thing is these are equals to 0. So what that means is I can take these two parts of the calculations and see what I can do. Okay, Fa is given to me in the question. I didn't write it out. Horizontal force, that is my Fa. 41 Newton forward. Okay, so I have 41 minus Ff equals to 0. Bring this over to the other side. This was minus, so I have to add it to the other side. So that's why I can say 41 newtons is equals to Ff. So I found Ff, which then I can sub it into here, right? Now I need to find what Fn is. So I'm going to use the y direction, okay? Fn minus Fg equals to 0. So that means Fn, is it okay if I move my Fg over? It becomes Fg to the right. Does anybody remember? If I'm asked to find Fg, do you know the equation to find the Fg? Hopefully you recall from the second law lesson. Okay, I know that every time when they're asking for Fg, it's the mass times the 9.8. So on the side here, I can do the calculation. Mass is 315 times the 9.8. If you don't remember them, that's okay. Write them out, right? Like write out your equation. So I have 315 times 9.8. So I got 3087. So if Fg is 3087, then Fn is also equals to 3087 newtons. And look, when I got that, I can now sub the Fn into this Fn. Do you see how like you have to separately find out what they are? So now I can sub everything into this equation because that's what the question wants. Ff is 41, Fn is 3087. So I just divide the two and I got the answer of 0.013. What's the unit for mu? We didn't talk about it. What is the unit for mu? Not Newton. Okay, let's take a look. Okay, we said that mu is Ff divided by Fn. The unit for Ff is Newton because it's a force. The unit for Fn is also Newton. So if I have something that has Newton divided by Newton, the unit is no unit, okay? So it's actually, mu does not have a unit. It's unit. This is going to be something I'm going to ask you on a test, okay? I'm going to ask you, what is the unit for mu? You're going to have to tell me it has no unit, unitless. Okay, so therefore this is my answer. So I'm done. No units. Last question. A truck. Brakes are applied so hard that the truck goes into a skid on a dry asphalt road. So mu is 1.0. If the truck and the content have a mass of 4,200 kilograms, calculate the magnitude of the kinetic friction. So force of kinetic friction on the truck. So I am given mu is 1.0, no units. I am given the mass, which is 4,200 kilograms. And they're asking you what is the FF. The actual calculation of kinetic friction. So that's FF, the force of it, right? Okay, so let's see what I can do. I know force of friction. I know the equation is mu Fn. I don't know what Fn is, so that means you need to find it. So just like always, you draw your free body diagram first. Okay, so this truck has force of gravity and it has force of normal. Does it have an applied force? The truck is brake are applied so hard, the truck goes into a skid. Applied force is like you're stepping on the gas. If you're slamming on the brake, it does not have an applied force. It only has a frictional force, okay? So these are tricky questions you're going to have to pick out. So you're going to go back to lesson 1, how to draw the free body diagram. Somebody asked me this question before, all right? So make sure you remember no FA in this question, okay? So let's talk about the forces along Y, okay? So we're going to do what we always do. The second step is we do our F net equals to MA. You can analyze it along X and Y, but because I'll look at what I have, this is the equation, I need the Fn. Does it make sense that I'll probably look at the Y direction first? I would probably look at these two guys and see what I can do, okay? So what I do is along Y, F net equals to up minus down. And hopefully you remember the acceleration is 0. The forces are balanced. The truck is going left and right. There is no unbalanced force. I don't know if you now figure it out. Fn equals to Fg. Okay, so Fn equals to Fg. Is it okay that I skip step? Because I move this over and makes it a plus. Okay, and hopefully you remember the equation for Fg is m times g. So the m, I'm going to just move it over to the left a little bit. Just going to buy myself a bit more room. So m times g, g is 9.8, 4,200 times 9.8. So it's a big number, 41160 newtons. So now that I have my Fn, this is my Fn, I can now take my Fn and I can now sub it into this value to solve for my FF. So mu, so FF is mu. In the question they gave it to us as 1. Fn is 41,160 equal, which is that number, 41,160 newtons.